Okay, question number 3 is a implicit question. It's asking us to find dy by dx in terms of x and y, and hence find the stationary points. So we're going to differentiate each of these terms here with respect to x, because x is on the bottom there. So the first bit, xy squared, is a product, so we're going to use the product rule. We're going to differentiate the first part, the x, which is 1, and leave the second bit alone. And then we're going to add on what we get when we leave the first bit alone, and then differentiate y squared with respect to x. To differentiate y squared with respect to x, we are going to pretend it's an x and differentiate, which is going to give me 2y. But we're then going to times by the differential of y with respect to x, which is dy by dx. I'll tidy this up in a sec. That's the hard part done, because the right hand side is just already in terms of x. So if we differentiate the right hand side, we're just going to get 2x. So if we just get rid of the brackets, this will be 2xy dy by dx equals 2x. We're going to need to make dy by dx the subject, so I'm going to subtract the y squared. And I'm then going to divide by the 2xy, so that we get dy by dx is equal to 2x minus y squared divided by 2xy. So that's the first part of the question done. It then says to find the stationary points. So we know that stationary points happen when, that's a w, when dy by dx is equal to 0. So we want to make this equal to 0. And that will be 0 when the numerator is 0. So we can ignore the bottom and just say 2x minus y squared needs to equal 0. The only time that's a problem is if x or y ends up being 0. So we can check that at the end. If x or y is equal to 0, this will not work because we'll be dividing by 0. But in all other cases, we can just ignore the bottom and set the top to be 0. So what that means is that at the stationary point, 2x has to equal y squared. So what we can now do is say that at the stationary point, because we know that 2x has to equal y squared, we can substitute that into here to get rid of one of the letters. And the easiest thing to do, you can see we've got a y squared there, so I'm just going to replace that y squared with what was it, 2x. So instead of writing xy squared, I'm going to write x 2x, because at the stationary point y squared is 2x. And then we're going to solve this. So that's what we can do next. So I'm going to come down to the next part, and we're going to write that, what was it, 2x squared equals x squared plus 1. If we solve this, take the x squared to the other side, then we've got that x squared is equal to 1. So x is either equal to plus 1 or minus 1. So that's the potential x coordinates of the stationary points. We know that 2x is equal to y squared, so y is also going to equal plus or minus the square root of 2x. So when x is 1, y is going to be plus or minus the square root of 2. And when x is minus 1, it all goes wrong. We can't square root. We're going to have negative 2 in here, which isn't possible. So that one we're going to ignore. This is what gives us our stationary points. So our stationary points are at 1 root 2 or 1 minus root 2.